Well, good afternoon, everyone, and welcome to today's special event. My name is Justin Peter, and I am working with Worldwide Quest. I'm pleased to be your host today for our webinar, Seabirds of the Southern Ocean. Worldwide Quest is a small travel company based here in Toronto, Ontario. We specialize in small group travel with a focus on learning and great experiences. And in addition to a whole suite of classic tours, we also collaborate closely with a number of institutional partners, including a number of Canadian universities, including UBC, the University of Alberta, McMaster, Western, McGill, University of Saskatchewan, and York University to create tours featuring idea leaders drawn from their communities. And it's possible that you heard about today's event through one of those institutions. Welcome to everyone. I'm pleased to be your host for our webinar today. Just to give you a little bit more of an idea of how this webinar will run, we expect this event in total will run approximately 45 minutes to 1 hour. Our speaker will be presenting a slide talk for about 35 minutes or so. Following that, we will have a question and answer period, which will run approximately 10 to 15 minutes in length. So we hope you'll stay with us throughout the whole presentation. This talk is being recorded, so in case you need to leave the presentation a little bit early, or if you'd like to share this presentation with someone you know, you will be, in fact, we will be sending you a link to the recording of this webinar so that you may view it later and also pass that along if you'd like. So just please know that. If you, or actually on the topic of questions, you should have a GoToWebinar console on one side of your screen or the other. Within that console, there are a number of tabs. One of those tabs is labeled questions, and it's in that place during our questions period, or at any time that a question pops or comes to mind during the presentation, you can enter your question there. And during the question and answer period, I'll be fielding your questions to our speaker, and we will proceed that way. So please look for that questions tab. We also have below the questions tab a chat tab, and in that chat tab we may be posting a number of different links to websites that you might like to check out during or following the presentation. So also please watch for the chat tab. In case you see my face and you hear me speaking, but you don't see a slide below my face, you should in fact be seeing the title slide to today's talk below my face. If you do not see that slide, there is a remedy for this. There should be 3 little lines, tightly packed lines below my face. And if you click on those lines, that should pop down a slide into view. So just in case you don't see that slide, please try that right now. Great, so that covers some of our technical components here. And I am pleased to introduce today's speaker, who is Catherine Jardine. Catherine is an avid naturalist and a traveler who follows her considerable interests in natural history around the world. She is a superlative communicator of the natural world. Catherine works as an ornithologist with Birds Canada, which is Canada's premier bird science and conservation association with different offices throughout Canada. Catherine is based in their office in Delta, British Columbia. And she's, as a field biologist and ornithologist, she's worked on a number of different projects, many of them focusing on seabirds, not exclusively, but often on seabirds, including Atlantic puffins on the East Coast, the rhinoceros auklet on the West Coast, and she's worked with a number of critically endangered bird species, including the flightless kakapo, which is a large flightless parrot, as well as the brown kiwi in New Zealand, as well as burrowing owls, which are an endangered bird in Canada, here in North America. She's also worked as an expedition guide in Antarctica, where her specialty is birds. Catherine grounds her interpretive style in an understanding of a region's ecology, the adaptations of its resident wildlife, and the current conservation challenges and solutions. Catherine, of course, will be doing the same here on today's webinar. We're so pleased to have you along, Catherine. And I should also mention that Catherine will be our ornithologist aboard our special Worldwide Quest Unspoiled Antarctica with South Georgia expedition that we have coming up this October and November that we're offering through a number of those Canadian University Alumni Associations. So without further ado, Catherine, we welcome you to our webinar today and really look forward to hearing a lot more and understanding more about seabirds of the Southern Ocean. Thank you so much, Catherine.
Thanks so much, Justin. That's just great. So welcome everybody. Before I move straight down into the Southern Hemisphere, I just wanted to start, one moment, before we move into the Southern Hemisphere, I just want to start here and acknowledge that I'm presenting this webinar from the shared traditional and unceded territories of Tawasin, Musqueam, and other Coast Salish peoples. And with them, we share an appreciation and a responsibility for birds and the natural spaces on which they depend. So it's really key that we think about the birds here as well as the birds elsewhere. So, from my own coast, I want to zoom out a little bit. And I really love how maps can shift your perspective on things. Almost every map you see is sort of centered in the Atlantic and is very land focused. But this map is centered on the Pacific, and it really is a reminder of just how big the oceans are. The oceans cover 70% of the planet's surface and over 99% of the biosphere. So that's the living space available on the planet. That is a lot of space and a lot of resources. And yet, with about 70% of the surface, only about 3% of all bird species are considered seabirds. In sheer numbers, though, some estimates that suggest that bird for bird, like in terms of the exact number of individuals, there might be just about as many seabirds in the world as land birds. But in terms of species diversity, it takes a lot of specialization for a warm-blooded, hollow-boned, air-breathing animal to survive the world's oceans. And so very few species manage it, and it takes a lot of very special adaptations to do it. But for those that do, the oceans are hugely productive. So this is a map of chlorophyll content of the oceans. We get this from satellite imagery. And as you can see, the areas there in green are more productive in terms of chlorophyll content, and that's an index of marine productivity. So in terms of everything starts at the base of the food chain and moves up, right? So lots of chlorophyll, lots of green plants and algae, that increases the productivity up the food chain. So in today's talk, we're going to be focused on the seabirds of the Southern Ocean. So if you look down at that Southern Ocean, you see all that green down there. So that's lots of food that's available for those intrepid enough to try for it. But there is a lot of something else down there too. Something that if you're a flying animal might complicate your life a little bit. And that is wind. This is wind speed, average wind speeds across the global oceans. If you look back down in that Southern Ocean, once again, you'll see that it is the windiest place on the planet. All those little red areas, the Southern Ocean is the only place on the entire planet where there's no land mass interrupting the ocean all the way around the globe, which means those westerly winds, that Coriolis effect that you get, actually whips around the entire globe and nothing stops it. And that's how it actually creates these high winds around the Southern Ocean. So up in the north, you have some productivity as well, and you have the auks. These are puffins and their cousins. Those seabirds still fly. In fact, those seabirds do everything. They fly, they swim, they burrow. They really have conquered all the different regions. But in order to swim very well, their wings are quite short. Long wings underwater cause too much drag, so they need to have very short wings in order to fly underwater, in order to swim very well, because they are pursuit divers. They're swimming underwater and catching fish. In the air, that means their wings are very short in comparisons to their body size. We call this having high wing loading, tiny wings for that chubby little puffin belly, right? That means a puffin has to work really hard to fly. They beat their wings up to 600 times per minute just to stay airborne. And if you add a little wind to that, or a lot of wind to that, flying becomes very difficult, in some cases next to impossible. I can personally attest to that because one of these guys gave me a black eye crashing into me as I stood still on a windy day. Not the best wind flyers. And then down south, where the winds are much stronger, the diving bird body plan really doesn't work well for flight anymore. The penguins, in fact, well, they just gave up on the whole affair, didn't they? And I mean, there's a bit more to the flightlessness of penguins than that, from lack of sharks, accessible nest sites, and really fully specializing on that pursuit diving and no longer making compromises. But I couldn't help poking a little bit of fun at penguins for swimming everywhere instead of flying. There is, however, one group of species that, instead of being excluded by the winds of the Southern Ocean, harness them. So these are the procelloforms. And that is not going to help you win at Scrabble anytime soon, so we can also call them by their other name, which is the tube noses. This is a group of about 100 species. That's less than 1% of all bird species in the world. It includes the albatross, shearwaters, fulmars, prions, and petrels. And we're not going to worry too much about the different groups and types of tube noses in this talk. That's really best saved for when you're on the water and seeing them. But for now, in this picture, you can notice their shared structure. As you can see, their body shape could not be more different than our stocky, cute, chubby puffins and penguins. These birds have long, slender, willowy wings and very streamlined bodies. They're not well suited for diving, but I bet you can guess what they are good for, and that is flying in the wind. So this is a northern fulmar. We get southern fulmars too, down in the Southern Ocean. And this is a tube nose. Good way to know that it's a tube nose. If you look at its bill there, you see a little tube on top of its bill. Ergo, tube nose. These guys have been really, really well studied up here in the Northern Hemisphere. And their metabolic rate has been studied in comparison to wind speed. So flying in calm wind conditions with no wind, they are flapping a lot and using up to 2,000 calories a day to stay airborne. That's the same as the average human consumes. It's so much flapping. But in ideal winds, they consume almost 20 times less than that, around 100 calories. It's the same amount that they would consume sitting on the nest doing nothing. Energetically speaking, in the right wind conditions, flying is the same as sitting for a northern fulmar. Can you imagine a world where sprinting took the same amount of energy as watching TV? So how is that possible when we know winds defeated our poor little puffin friend? Well, it's a process called dynamic soaring, and it takes advantage of the way ocean winds work. So let's start with the wind. Wind at the surface of the ocean is slowed by friction. Energy from the air is transferred into the water. You see that as waves. And you know, the windier it is, the more waves there are. That's because energy from the air is going into the water. That means energy is being lost from the air that is close to the water's surface. The air moving along the water is moving slower than the air moving further up. That differential is what the albatross and tube noses are taking advantage of. They turn into the wind, and the wind moving faster above their wing and slower beneath their wing, that generates lift, and they gain altitude. Then they turn, and they fly downwind. That generates speed, and a lot of speed. Then they go back up, altitude, back down, speed. I'd repeat that over and over again. You notice nowhere in there did I say they flap, because they don't. They can reach up to speeds up to 65 kilometers an hour without flapping, all when just sitting on the wind. They don't even need to expend energy to keep their wings open. Their wings lock into their sockets, and all that's needed is slight adjustments to control tilt and direction. Everything else is powered by the wind. That means tube noses are almost the opposite of most birds. The windier it is, the better they fly. One of them is actually called the storm-petrels because they are found so often flying in storms. That's a major advantage if you're trying to travel long distances on a windy ocean. And the longer your wings are, the better. Which leads us to the longest wingspan in the world, that of the wandering albatross. At 3 meters, or about 12 feet. This is me beside a wandering albatross in the South Georgia Heritage Trust Museum on South Georgia, one of the places we stop on our trip. As you can see, one of this bird's wings is the length of my entire body. And this is not the record holder. They also had to tuck it in a little bit to get it to fit below the ceiling. So albatrosses are huge. Even the smallest has a wingspan of over 6 feet. These are very, very big and interesting and impressive birds. So you'll recall our two plots. One of ocean productivity, so lots of green around the Southern Ocean. The other of wind conditions, so much red around the Southern Oceans. So any predictions for the distribution of the world's albatross? It's exactly like you'd expect. There are about 3 species that live up here on the BC coast and nest in Hawaii or Japan, but the other 85% of them are all Southern Ocean specialists. In fact, albatrosses don't cross the equator. The winds are too calm there, and they rely on wind-assisted flight. So they're really focused on that Southern Ocean. But that's a lot of space still, and a lot of ocean. And as great as these birds are at flying, they are not entirely divorced from the land. They still need to nest onshore. And that land needs to be free of predators. And I'll explain why a little bit later in the presentation. And as you can see here, there isn't abundance of small offshore islands. So these guys really focus on areas where there are these small islands. This is a pair of albatross, black-browed albatross on the Falkland Islands, one of the places we stop, and they're in a big colony of hundreds of other birds. And they're all concentrated there because that's where the land is, and that's where the land is predator-free. But what happens if the small island where nesting can occur is nowhere near where the food is? Food can be hundreds, if not thousands of kilometers away. But to an albatross, that's really not a big deal. These that you see on this plot here are foraging trips of GPS-tagged albatross on the island of Crozet. A foraging trip is a bird leaving the nest, going out to get food, and coming back to feed the chick. And the one thing I'd like to point out here is that scale bar. You see that white bar down on the bottom left? That's 500 kilometers, 300 miles. That means the largest track on this map is 4,500 kilometers long for a single foraging trip. Imagining traveling 4,500 kilometers to pick up groceries. To put that in context, that's the distance from Vancouver to Toronto. So Justin could come over to my house for dinner and then go home the same night. But remember, energetically, flying is the same as sitting for these birds as long as there's wind. It's no big deal. But you might notice one thing that seems like a bit of a big deal there, and that's the number of days, that line of text at the very bottom of the screen. These birds leave the nest for a very long time to go out for these foraging trips. In fact, the record is 50 days, and you probably wouldn't leave your child unattended for that long at a time. But these birds are well adapted to that. So here's a little fluff ball. And well, little might not be the right word. In fact, these chicks can actually weigh more than the adults, which is very unusual, particularly in the bird world. But without the constraints of needing to maintain that trim waistline to allow for flights, these fatty little guys have abundant reserves to last between those foraging trips. So while adults average around 9 kilograms, the record weight for a chick was 16 kilograms. There's another theory too for why the chicks are so much heavier than the adults, and that is the doorstop effect. Basically that the chicks need to be fairly heavy to prevent them from being blown off the slopes. So that's a big chick to make. You know, creating a chick that's even larger than yourself, that takes a lot of effort. It takes up to 300 days to fledge an albatross chick and about 100 kilograms of food. So how do they find that much food in that massive ocean on those long foraging trips? Well, tube-nose are the bloodhounds of the bird world. These birds have incredible senses of smell, and they have the largest olfactory bulbs of any bird species. An albatross can locate food up to 30 kilometers away. I'm going to pick on the puffin one more time, only because I love them so much. This shows the brain structure devoted to the sense of smell of a puffin in comparison to a snow petrel. Snow petrel is also a tube nose. You can see a little tube on the end of its nose there. As you can see, the snow petrel is devoting a lot more of its brain space to detecting smell than the puffin is. And that makes sense, given that the petrel is finding food using smell, and the puffin is generally finding food using eyesight. You can see its big eyes there. So the other thing that these birds are able to do is pick up the scent of something called dimethyl sulfide. That's a compound that's released when phytoplankton, so the green plankton in the ocean, are predated, so fed on by zooplankton. And something that likes to eat zooplankton are tube noses. Birds can zero in on this chemical to find their food. Unfortunately, there is something else that also releases dimethyl sulfide at sea, and that is marine plastics. I'm not going to say too much more about marine plastics and seabirds at this point because it's kind of a talk in and of itself, but it's safe to say that many seabirds are ingesting at least some marine plastic. Many adults can avoid larger plastics from their systems, but that's not always true for chicks. And this is just one of the reasons why we as humans need to both rely less on single-use plastic and prevent what we do use from entering our oceans. Beyond finding food or plastic, olfaction may be a major component of navigation. At sea, there are really no visual landmarks, right? You just see this expanse of ocean. Yet these birds return from their foraging trips thousands of kilometers quickly and directly. So how are they navigating? Researchers have investigated a bunch of different reasons for this, and one that's really started to come out on top is olfaction and olfaction's role in navigation. In a series of studies, birds had their senses of smell temporarily removed by exposing them to a chemical called zinc sulfate. The birds were then transported hundreds of kilometers away from the breeding colony and released. Some birds had their sense of smell altered, other birds did not. Those are the control birds. Control birds that were able to smell normally were back at the nest site the same day. They beelined it straight home. Birds that had had their sense of smell altered were delayed. They also even compared this to magnetic navigation versus scent navigation. And the birds that had their scent altered as opposed to their magnetic detection still returned less quickly. The theory for this is that the birds are getting clues to where they are based on scent. So you might see a bathymetric feature, that's the topography under the ocean. Maybe you have a seamount or something along those lines. And phytoplankton might assemble near that seamount because you get upwellings and that's where nutrients are. And that assemblage of phytoplankton would create an odor feature. So the idea is that there's an odor landscape at sea that these birds are able to detect that provides them with these navigation clues. It's a really interesting way of navigating the world. So that's how they manage some of those long foraging trips, dynamic soaring and olfaction. But the pairs don't make these trips together. So how does one maintain such a long distance relationship? The pair spend very little time together, right? They alternate off incubation with one another and do solo foraging trips. For seabirds, parental care is almost always shared 50-50. You need both parents to be out foraging and to be incubating in order to successfully raise a chick in these environments. So there's really a huge amount of trust, and I don't see a less anthropogenic word for it involved. So pair bonding is really a key part of the breeding process, which, remember, that breeding process takes 300 days and it happens once every 2 years. So it's very costly to do, and it's therefore a key part to get your pair bonding established before you embark on this process. And pair bonding includes these ritualistic dances, lots of allopreening. And this is something that I've actually never had the pleasure of seeing personally. I'm really hoping to get to witness it this year. We'll be going slightly earlier in the season than I've been to South Georgia before when these birds will be dancing. So I'm really, really excited about this in particular. particularly because pair bonding in albatross has like cultural significance for us as well. Like you may have heard that albatross mate for life. And that's largely true. Less than 1 to 3% of pairs tend to divorce annually, which is incredibly low for birds. And a divorce is usually the result of a failed breeding attempt. So there was a really interesting study published last year, just last fall actually, that found that divorce rates were dependent on temperature. So divorce rates, if you look at the graph on the right here, the temperature is the one axis, and so sea surface temperature increases as you move to the right, and divorce rates increase as you move upwards. So the hotter it got, the more likely it was for birds to divorce. And that makes some sense. The author proposed the partner blaming hypothesis. So in warmer years, there might be fewer fish and phytoplankton for adults and their chicks to eat, and nesting may fail. And a failed nesting attempt is really a divorce-worthy event. These birds do not breed until they're about 10 years old, and then it takes 2 years to hatch a chick. Breeding is very costly. So if you fail breeding, it kind of is natural to potentially blame your partner and divorce. And that's why we're seeing these changes in albatross divorce rates depending on sea surface temperature. So why adopt such a costly breeding strategy at all? Well, if you think about it, it's actually our strategy as humans. There are two sort of main camps for ecological strategy. One is to have a fairly short lifespan, but make lots of babies. This is called R selection, reproduction. These are your bunnies, right? They don't live very long, but they're very good at reproducing. The other option is K. K is actually short for lifespan. It stands for lifespan, where you have a long lifespan, really high investment in your offspring, and very little offspring. So you have very few offspring. And as you can see here, the wandering albatross is definitely a K selected species. They have the lowest reproductive rate of any bird on the planet. So if you're going to have a reproductive rate that low, you really need the lifespan to back it up. And they do. So meet Wisdom. Wisdom is a Laysan albatross, and she is the world's oldest known wild bird. This is her on February 1st, 2021, tending her most recent chick. Biologists first banded Wisdom as an adult bird in 1956, meaning that today she is at least 7 years old and still breeding. This long life, low reproduction is a great strategy, especially in variable habitats like the ocean, where you might need more than one chance to breed successfully. You'll have El Nino years, La Nina years, you might have years where you're not able to find as many fish. You are able to have that long lifespan to give you many chances to successfully breed and reproduce. And it's really good in cases where more knowledge, like learning scent landscapes to find your way around, improves breeding success. But it is really contingent on that long life part to be successful. So populations of these birds are particularly sensitive to mortality rate. So let's talk a little bit about conservation and mortality of these birds. Seabirds are one of the most threatened groups of birds in the world. Of pelagic seabirds, those are the ones that we're talking about. Those are the ones that the tube nose belong to. Pelagic means they live most of their lives at sea. More than half of all species are listed by the IUCN, the International Union on the Conservation of Nature. They're either listed as critically endangered, vulnerable, or near threatened. That is a huge proportion. And not surprisingly, here is where they live. This is the distribution of threatened seabirds of the world. Interestingly, where you're seeing the most red there is also some of the most remote locations on the planet. So what is driving these declines? Well, there are two main reasons, and unfortunately, yes, they are our fault. But before I talk about them, I just wanted to say that I'm going to show just a couple images that might be a little hard to see, and they are for me personally as well. But I do think it's important, and I just wanted to give that warning first. So the two main causes of mortality are fisheries bycatch and invasive predators. I'm going to talk about invasives first. These birds are not adapted to dealing with predators, and invasive mammals are able to attack eggs, chicks, and even in some cases, adults. And that's been a major problem on some of the islands where these birds breed. So there's two main examples that I'm going to talk about today. One is South Georgia Island, one of the places we go on our trips, and the other is Gough Island, which is about halfway, it's on the sort of other side of the Southern Ocean. So South Georgia had rats introduced by sailors about 200 years ago, and the need to remove them was really high. A lot of small seabirds, a lot of the tube noses were exterminated from any areas that contained rats. And the estimates that were that seabirds nesting on the island used to be about 10 times higher than they are now, and were likely to go extinct without rat eradication. So there was a really keen interest to remove the rats that had been introduced to South Georgia. And the glaciated nature, you can see in the top right, there's a lot of glaciers on South Georgia. That made the effort a lot more urgent. So glaciers block dispersals of rodents. Rats don't cross glaciers, meaning that the island could be eradicated, the rats removed one section at a time. And so there was really a push to get this done before glacial retreat took away this advantage. And I'm really pleased to say that it worked. On May 8th, 2018, South Georgia was officially declared rodent-free for the first time in 200 years, which was absolutely an amazing achievement. It took 2 helicopters, 300 tons of bait, 4 seasons, dog teams, tons of volunteers. It was a massive undertaking. And we're already seeing results of this. For example, this is the South Georgia pipit. It was threatened with extinction because of rats eating its eggs and nestlings. I had the pleasure of getting to guide to South Georgia before the rat eradication and after the rat eradication. This is one of the rarest songbirds in the world and the most southerly songbird in the world. And so a lot of people on the trips would want to see it, right? And before the rat eradication, that was a challenge. It was hard to find a South Georgia pipit for folks. We always managed it, but it was a challenge. Now they are everywhere. You hear them singing from deck, hear them singing everywhere, they're flitting around. It's made a huge difference. And South Georgia pipits, they definitely are selected, right? Shorter lifespans, more reproduction. We're hoping to see the same with some of those K-selected species, those longer-lived seabirds that will take a little bit longer because it's only been 4 years at this point, and we're expecting some of the birds that might have survived in those first few years to start coming back to breed soon. It's amazing. It's the biggest rat eradication that's ever happened in the world, and one of the greatest conservation achievements for these birds. The second example is Gough Island. It is also considered to be one of the world's most important seabird colonies. It hosts about 10 million birds, a few of them, like the Tristan albatross, critically endangered. Again, mice were introduced during the 19th century, and these rodents, these mice, have adapted to the limited resources on this land by, unfortunately, developing a taste for seabird eggs and chicks. And now we're even seeing adults being attacked while they incubate. What's happening is that during the abundant summers, the mouse population goes up because there's lots of food, and then the winters come and the mice no longer have enough food and they switch to attacking the birds. So last year, an effort was made to remove the mice from the island. So Gough Island actually was more challenging than South Georgia. It's not glaciated and it had quite complex topography. They spread bait across the entire island using helicopter pilots. And they finished this last summer. And unfortunately, in December, a mouse was spotted on a camera trap on the island. They investigated and did find more than one, which was completely heartbreaking. They think that what might have happened is that the island has several introduced invertebrates as well, and the invertebrates might have consumed the bait before the rodents got to it. So although this was not fully successful, they didn't achieve their goal of removing every last mouse from the island. It will bring some temporary respite from predation for the next few years, and the group has not given up yet. They're definitely still working on it. There's lots more to do for these birds when it comes to invasive predators, but prevention, biosecurity, remains the most important step for when we visit these places. The second threat faced by these birds is fishery bycatch, particularly for long line fishing. The birds smell the bait and come in and are caught on hooks that are targeting fish. And this was one of those cases that were bad for the birds and bad for the fisheries. So BirdLife International commissioned the Albatross Task Force to try and address this problem for both the birds and the fisheries. And it worked. Man, did it work. 3 simple changes made a massive difference, reducing mortality rate by 99%. It's not often that you get a good news story that's this good. There were 3 main changes. They included bird scaring lines. Those are those red ribbons that you see being pulled behind the boat. As you can see, the birds are giving them a wide berth. They don't like them. Setting the lines at night instead of during the day. A lot of these birds don't forage at night. And weighting the line. Remember, these birds, not so good with the diving, right? They can dive, but it's fairly limited. They can't swim down deep. So by weighting the lines, it got the line out of the reach of these birds more quickly and reduced the window where they could go after the bait. They estimate that about 22,000 birds have been saved every year by making these changes. So it's a huge conservation success story, which I love telling conservation success stories. Simple and cheap measures that are good for birds, good for people, and really have no known downsides. So the task force is working to get more vessels and countries to adopt these measures, and including them in things like Marine Stewardship Council certification of sustainable seafood. So this ship following behavior used to be a bit of a death sentence for albatross and other tube noses, but it isn't likely to be for much longer. And now scientists are even trying to harness it to help other species, including our own. So overfishing and fisheries collapse is a major conservation, food security, and economic threat. Lots has been done to try and address this threat, and many regulations exist on fisheries globally. However, policing these regulations on the ocean is notoriously next to impossible. Finding illegal fishing in the vast expanse of the ocean in order to prosecute seems like an insurmountable task. Unless, of course, you happen to have adaptations that make you perfectly suited to finding and following fishing vessels. And we now all know someone who matches that description and also happens to be big enough to carry a GPS transmitter. So here are the tracks of 169 albatross that were tagged with these GPS trackers in the Southern Ocean. And then what the scientists did was they were able to analyze the tracks and find where the birds were following boats. There was very characteristic behavior when a bird is following a boat. They then compared that data to the vessel identification systems that legal fishing vessels have to have. And that meant that the researchers were able to pinpoint illegal vessels. Anytime a bird was following a ship that was not using one of these vessel identification systems, that was indicative of an illegal vessel. So as you can see in this plot, all the green dots are ship following behavior on legal vessels, and all the red dots are ship following behavior on illegal vessels. This data, we're hoping at some point to allow this to be used to deploy enforcement in real time to these locations. But even if not, this data really helps quantify and understand illegal fishing. So after pushing many of these species to the edge of extinction, we now may end up actually relying on them and their amazing adaptations to life at sea to help save us from ourselves. And I can't think of any better metaphor for resilience than that. So I hope this gives you a small little window into the lives of these ocean wanderers. They are really, truly remarkable creatures. They have amazing adaptations, resilience, and they're just elegant, really. And they have captured our imaginations from Rhyme of the Ancient Mariner, all the way through to like Monty Python, right? And what I love is that these birds also follow our vessels as we explore these areas. This photo, for example, is of a black-browed albatross that I took with my phone from the bridge of the ship. They just cruise around us and behind us. And so, as much as when I'm in Antarctica, I love visiting the penguin colonies and seeing the seals and the ice floes and all the beauty that's down there, one of my really favorite parts is just the journey there, because I get to stand at the stern of the ship or on the bridge and just watch these massive and graceful creatures dance through the wind. And that's really just a privilege. So for anybody who wants to stand beside me while I do that, we're going back finally this fall. I'm really, really excited to get back down south. And from here, I'll pass it back over to Justin to answer any questions you might have.
Great. Well, thank you so much, Catherine, for that illuminating talk. I love this idea of tracking vessels with the albatross, a total novel concept, turned the world on its head, I guess you'd say.
I love it when an animal can do something so much better than any of our technology.
Yeah, it's pretty amazing. And the longest lived bird, known bird as well, that lays an albatross, that's also a fantastic story. Just
Wisdom, yeah.
that they could do that, and that it wasn't even known, that we don't actually know her age. We just know that she's at least 70
She's
or so years
at
because
least 70, yeah. And then Laysan albatrosses are one of the smaller albatrosses. Their wingspan is only around 6 feet, and oftentimes, like lifespan is correlated with size. So we
yes.
have no idea how long some of the wandering albatross might live.
Well, that's great. We do have a couple of questions here. If any one of you in the audience have any questions, please don't be shy. Type your question into the questions tab in your GoToWebinar console or one side of your screen there. I did have a couple of questions here that I'm seeing. One of them regards the bones. And albatross and their bone structure. I guess I understand that most flying birds have hollow bones. I guess there's some exceptions, or birds with particularly heavy bones, but hollow bones allow a bird to be lighter weight, that allow it to fly with greater ease. Can you comment on the bone structure of albatross and other tube noses, and how they may be specially adapted to facilitate flight or weightlessness, if that's possible?
Yeah, well, I mean, it's one of the most obvious, and I don't even need to say it, is their wing bones are longer,
Yeah.
certainly. And as a group, they have a lot more feathers along their wings. Like almost all passerines, those are like the songbirds you see in your yard, have about 9 or 10 primary feathers, and they almost all have the same amount. But the albatross and the tube noses have many more feathers to cover their wings. So instead of just making their feathers bigger, they created more of them. They do have that hollow bone structure. A lot of what birds do in terms of their adaptations are designed to reduce weight. And so even bills are part of the weight reduction strategy. The bill structure is much lighter than having a jaw and teeth. Teeth are quite heavy in comparison to a bird's bill. And so there are a lot of those adaptations. I don't know that albatross and tube noses have any more specific to trying to lighten their bodies. They have a lot more of adaptations trying to keep them buoyant on the water and waterproof. So they'll have a lot of oils coming from their uroptygial gland. That's a little preening gland at the base of their tails that they'll spread over their feathers to keep them nice and waterproof at sea. And one other thing that I didn't talk about in this talk, but I find really, really interesting is their coloration actually is helping them fly as well. So a lot of these seabirds you'll see have black tips to the wings. You'll even see this in gulls in your yard. Those black tips, they heat up in the sun, whereas the white on the rest of the wing stays cool. And that temperature differential helps reduce drag on the wings and help them fly better. So even down to their coloring, we see these adaptations for flight.
That's interesting. Andy, thank you for that. Now, Andy is asking a question about the plastics. You're talking about single-use plastics, and I'm wondering if you can comment chemically on a chemical basis, what types of plastics have been found in birds, or which are the ones that are being found? I mean, single-use plastic is sort of a generic, broader term, I guess, but are they polyethylene or polypropylene, or do we know if there's any relationship with what the birds are picking up in terms of the type of plastic itself?
Yeah, we know more and more and more as time goes on, and there's tracking of more and more what we're finding about different species that are doing this, and also microplastics as well. The short answer is it seems like all of them. Someone that I knew did work on Wandering Albatross, and they brought back a bag of plastic that had been swallowed by albatross, and there were poker chips in there, lighters, a ton of different plastic fragments from things like plastic bottles, milk jugs, that sort of thing, because they're both scent predators and visual predators, and they are more surface skimmers, right? They're not diving for their food, they're grabbing things off the surface. So if they see something floating out at sea on the surface, they're going to grab it, and that's oftentimes plastic. This is less prevalent in the Southern Ocean, and that is because of something called the Antarctic convergence. And that is basically an ocean barrier that exists between the Southern Ocean and the Pacific or Atlantic Oceans. It's basically an area where the water doesn't mix very much, and that's maintained by that spinning wind around around Antarctica. So we have seen less plastic invading into the Southern Ocean, and it is less prevalent in those seabirds, though it's still happening. It's really particularly bad for those three Pacific nesting species. The Wandering albatrosses in particular are consuming a lot of plastics, and as far as I know, it's everything.
Great, thank you for that. Roger's asking a question that might I wonder if you can address, because you have worked also and lived in New Zealand, Roger, and you're discussing eradication of introduced species such as rats. So he's asking about the reintroduction of native birds in Titimatangi Island in New Zealand, where they removed rats. Can you comment on that?
It worked. Yeah, and I mean, I've gotten to work on some of the predator-free islands in New Zealand, and it is amazing the difference that you see between a island with predators on it and an island without it. Just as a primer for everybody else, New Zealand didn't have native mammals except for bats and seals, ones that flew or swam there. It broke off from Gondwana land long before mammals originated. So there were all niches in New Zealand were occupied by birds. Interestingly, New Zealand birds have very unique smells because they were not at risk of being hunted by scent-based predators, which a lot of mammalian predators are. A kiwi, you can smell, like I can track a kiwi by smell. It's really, really weird. But the introduction of predators on the mainland has caused a lot of extinctions and a lot of very threatened birds. And so New Zealand, the Department of Conservation there has put a lot of work into refugia, which are these offshore islands that they maintain predator-free, so these little oases where they try and maintain these populations. New Zealand has a really ambitious plan right now to have their entire island be predator-free by 2050, and they're working really, really hard on that. It is a very ambitious plan, but they're making progress, and pretty much everybody in the country is working together and is behind them. So it's a really, it would be an amazing achievement if they managed it. But yeah, once you have predator-free islands, these bird populations rebound fairly quickly.
I have two questions that I think are sort of, they might be sort of connected. One is from Julie, who's asking, do any albatross nest on Antarctica? Meaning, I believe, Julie, you mean on the continent of Antarctica.
On Antarctica proper. No, they do not. In the only, there is one colony of albatross on New Zealand, of wandering albatross on one peninsula on New Zealand, but otherwise they're island people.
Okay, they're further afield. Now, the other question that I thought might be related, but you can maybe enlighten on this, us on this. We talked about the wind, the Coriolis effect, the Antarctic convergence, which is where the Atlantic and Pacific Oceans meet the Antarctic, and around that belt, basically that meeting point is where you have the winds that are at their strongest. The tube noses are you taking advantage of that to engage in dynamic soaring. Kristen is asking, is the spinning, when you're talking about that wind, I think she's referring to spinning wind, but is that what we call the roaring 40s?
Yeah, on our end, yeah, for sure. There, it just doesn't have any land that gets interrupted by it. I should say one other thing, that there are tube noses that nest on Antarctica proper, just not albatross. So Wilson's storm-petrel, snow petrels, which are those absolutely beautiful, pure white birds with just black eyes and bill and everything else just shining white. They are some of the most southerly nesting birds in the world, actually. They're beat out by the emperor penguins, but other than that, they go fairly far down south. And then like your southern giant petrels, lots of tube noses nest on Antarctica proper, just not albatross.
Now, if I can just add to that, sort of to those questions, is it because for albatross, do we infer that they require more wind? Do the birds with the longer wings require more consistent, strong winds? And is that the reason, is the lack of wind around Antarctica proper, can we infer that that's why albatrosses are not nesting on Antarctica?
Yeah, that's what I infer as well. Like there are some tube noses that are a bit more flappy than an albatross will be, right? And you can see this when you're out there. If you're out there in calmer winds, the albatross will be sitting and some of the smaller birds will still be out and about, right? Even sooty shearwaters, the sooty shearwaters that we have off the coast here in BC, they nest in New Zealand. So they're crossing the equator. They're doing a huge migration from New Zealand up here and then back down to nest. And so those birds are able to fly in calmer winds, but that 12-foot wingspan really needs a little bit of power to keep it going.
Interesting, very good. So supremely adapted, but sort of specialized in the requirements as well. Herb is asking, what other kinds of predators besides mice and rats, like the introduced predators, what other kinds of predators would these seabirds face?
Yeah, it's a good question. Here in BC, raccoons, mink, invasive cats has been a problem on particularly any island that had a lighthouse on it, often would get cats, just because we like them, and as we should. I like cats. Are big ones. In New Zealand, stoats, which are a type of mustelid, a weasel, similar to mink here. There have been, those are, I think, the main ones. Down in the Southern Ocean, it's largely rodents that have been introduced. Although there are some cases where you have introduced mammals that are doing things that indirectly hurt the birds. So, like, for example, goats in the Galapagos did a huge amount of damage to just the general ecosystem there, even though they weren't consuming the birds directly.
Interesting. Great.
And reindeer, they removed all the reindeer from South Georgia before they got to the rats. They had introduced reindeer for some reason. It was for sailors to hunt when they came by. Yeah. But.
Interesting. I was not aware of that. That's a very, very interesting point. Let's see. I'm just looking at the other questions here. Of some that relate to. Well, I have a question. Actually, there was another question. Here was about penguins. Of course, you were talking about seabirds of the Southern Ocean, in which you focused on the flying ones, the ones that fly in the air.
I'm trying to like,
Now, do
bring up the
penguins,
albatross appreciation, right? Like
yeah,
everybody
yeah,
loves penguins, but let's talk about the
penguins.
albatross.
So do penguins qualify as seabirds, or are they just,
Yes.
I mean, they're in the sea, they're obviously swimming, eating
Yeah.
things that they're finding in the ocean.
Yeah.
Where do they fit in?
They're seabird. Yeah. They're seabird. Absolutely. Yeah. Possibly, arguably, the seaiest of seabirds.
That's cute. That's
Yeah.
great. Um, Don is asking are there other birds besides the tube noses that have extra wing joints? I believe he might be referring to the
Not
feathers.
not joints, feathers. Yeah,
Feathers,
feathers.
yes.
And yes, yeah. Some of the raptors, like if you picture a condor, they have many as well. So yeah, they're not the only ones, but they definitely have the longest length wings in comparison to body size. Like if you see an albatross land, it's very awkward looking there. Like their quote unquote elbows end up way out back, and they're like trying to fold in their wings. It's like trying to like fold up your tent. Get it to fit.
Now, I have a couple of side questions that are related to seabirds, but more of the northern hemisphere.
Bring it on.
Andy is asking, well, just because you mentioned puffins, Andy's asking why do
I know
some
it's
birds,
hard
like
on the puffins. Let's be nice to the puffins.
how do the puffins in the northern hemisphere, how do they stack so many fish into their bill?
Yeah. So that is a mystery that I've thought about as well because they come back and they're just bursting, right? So they have these little backward facing spines on their tongue and on the roof of their bill as well that help once they get a fish in there, help prevent it from sliding out. And then I personally, based on some of the scars on my hands, can attest that they have very powerful bills and are able to clamp down very, very hard. And so they're able to hold on really tight despite the drag that they're experiencing through the water.
Interesting. So they grab one, it goes back, they grab another, and they just keep stacking them in as many as they can fit, and then they fly off to the nest with
Yeah,
their
and
cat.
they like the fish that they have in their bill, they're not alive anymore. They are able to kill them with that compressive force. So they, I'm sure, will also like be able to rearrange a little bit in the water because those fish will float, right? So
Yeah. I have one final question, also related to the northern the northern hemisphere, and I kind of want to volunteer an answer for this to Gloria. Gloria is asking that, or mentioning she's going to Newfoundland and Labrador this June, and one goal is to see puffins, and Gloria's asking, what should I especially watch for? And I wanted to add, what should she watch out for, and suggest that she should watch out for a flying puffin, so that a puffin doesn't fly into her head as it happened to you.
yeah, I think she'll be safe. Yeah, and like being in a puffin colony is really really cool. And you'll see what it depends a little bit on what time of year you're going to be there.
June. It's
June,
June.
okay. All right. In June, they'll be like just like incubating and finishing up, starting to hatch out some chicks. And so you might see some adults billing, which is one of those potential pair bonding behaviors. They'll be bashing their bills back and forth against one another. Like most seabirds, it's 100% shared parental care for puffins. And that's why you don't see a lot of sexual dimorphism in seabirds. So you might like, for a lot of birds, the male is that bright, flashy, pretty peacock, right? And the female is fairly drab. That doesn't happen with seabirds. The females and males almost, in most cases, look the same, and because they're both signaling to each other of their quality, because they both have to contribute the same amount to rearing of the chick. So in terms of telling sexes apart, you can only really do it if you take calipers and you measure the depth of the bill. That's how you will be able to tell the sex. And even then, you just figure out which one is bigger of a pair, and the bigger one is usually the male. Like there's an 85, 90% probability. So you might see some of that pair bonding going on. You might start seeing some foraging trips of them heading out and coming back. They'll do that throughout the day. They're very, very diurnal. Their chicks do not handle being left alone for long periods of time. So they'll be in and out on a regular basis. So lots of activity at a seabird colony for sure. And see if you can hear a puffin call, because they do not sound at all like you would expect. The best description I've heard about it was electronic bees.
Very funny. Very, very good. Great. Well, thank you so much, Catherine. That's been a fantastic presentation. There's many thanks from some of our attendees here in the questions tab. I think you make just the idea of watching seabirds sound really
Oh, it's
interesting,
so good.
whether it's going to
So
be
good.
on the deck of our vessel, the Magellan Explorer, this coming fall, or at the colonies themselves. I know we'll be visiting colonies in the Falkland Islands, on South Georgia, and as well on Antarctica proper. So it should be very interesting. If you have not signed up for our fall Antarctica and South Georgia expedition, I've put into the chat tab the link to our online magazine, or you can visit the site that's referenced here on the screen in front of you, worldwidequest.com/Antarctica. Thank you so much again, Catherine. We'll look forward to learning from you as well further aboard, and thank you for giving us this opportunity. Thank you for introducing us to seabirds of the Southern Ocean today.
Yeah, well, thanks for the love of the tube noses as well. That's great.
Thank you everyone for joining us today. Bye-bye.
Bye.